Right, welcome my 7th math class. This week I am pre-recording my video instead of last week doing it on the Zoom session. That way I'm able to put this video on to Canvas, and that way you can rewatch it, and that way we don't have any interruptions. I can pause the video in the middle of our Zoom session, see if anybody has questions. So this week we're still going along with probability, and I already included the 2 vocabulary words for this week. So this week we're going to be looking at probability models, which we have here. A probability model is a description of some chance process, and it includes 2 things. There's going to be a sample space, and then there's a probability for all of the outcomes. Okay, a sample space is the set of all possible outcomes. So really a set is the same thing as a list. So set really means list of all possible outcomes. Now, what we're starting this week, I'm going to be showing you some tree diagrams, and basically we're going to have 2 events happening. So an event was our vocabulary term last week. So that is something that is occurring, something that we have to choose between, or something that's happening. We're rolling a die, we're spinning a spinner, we're picking a number. That's an event, okay? So now we're going to have more than one event. So this first example, Matt wants to take a 3-day weekend trip to visit his grandparents. He can take either Friday or Monday off of work, and then, so he has to make a decision between those 2 days. And then the second part, he can then choose if he wants to fly, drive, take a train, or take a bus. So he has 2 options for the Friday or Monday, and then he has 4 options for the fly, drive, take a train, or take a bus. So those are the 2 events that are happening, okay? When we create a tree diagram, the first thing we want to do is what's the first thing we have to decide between. So the first thing was either Friday or Monday. So I'm going to list those 2 things down because those are the 2 things that could possibly happen. All right, now a tree diagram has branches coming off of whatever our first event, whatever happens in that first event, well then what could happen for the second event. So that's why we call these tree diagrams. Now the second possibility here, or the second event that we're doing, is the fly, drive, take a train, or take a bus. So there are 4 things that could happen there. So let's say Matt chooses he wants to take Friday off work to take that 3-day weekend trip, but then after he chooses the day Friday, he has 4 different options that he could choose from. He could fly, he could drive, he could take a train, or take a bus. Okay? Now, let's say instead of choosing Friday, maybe he said, nah, I'm going to take Monday off work for my 3-day weekend. Now, the second thing that he has to choose from is how is he going to get there? Well, they're still the same 4 options. He can either fly, drive, take a train, or take a bus. Okay, so what we just did was a tree diagram. Now we have every single option listed here. That's called a sample space. So our sample space, we could say that, and we could list every single one out, and usually we do, and usually we abbreviate it. We use these little squiggly, I'm not very good at them, these little squiggly parentheses, so we could say he's going to take Friday off work, and he's going to fly. He's going to take Friday off work, and he's going to drive. Friday off work, take a train. Friday off work, take a bus. So there are the 4 options there. And then, or the other 4 options come from Monday. So he could take Monday off work and fly. He could take Monday off work and drive. Monday off work, take a train. Monday off work, take a bus. And we'll end it with that other squiggly line. I'll fix. This one doesn't look very nice. There we go. So this is what we call a set of all possible outcomes, or the sample space. So right there is the sample space. So we have 8 possible outcomes. Okay, now we use these tree diagrams so that we can find probability. So what is the probability of leaving Monday and flying? Okay, well, let's look at our tree diagram. Well, here's Monday and flying. There's only one possibility here of leaving Monday or taking Monday off work and flying. And then that is out of, we already figured out, there's 8 total possible outcomes. So 1/8 is our probability of leaving Monday and flying. Okay, what is the probability? I'm going to change colors here. Let's do purple. Of leaving on Friday, so here's Friday, and driving or flying. So now we have that or word. So here's Friday flying. Here's Friday driving. So now we have 2 favorable outcomes, what we're looking for. Okay, and it's still out of a possible of 8 outcomes. So 2 out of 8, now we can simplify that to 1/4. Remember, we can change these into decimals, percents. For today's sake, I'm just going to keep them as fractions for our probability. So there's our probability on leaving Friday and driving or flying. Okay, so there was our first example. I'm going to go to the second page then and do one more example with you. I'll tell you, my husband and I have been playing a lot of Skip-Bo recently, and this probability is coming into our topic that we're talking about. I sit there, you get 5 cards in your hand, and I'm looking for one card. Well, there's one card, but if you've played Skip-Bo before, there's numbers 1 through 12, and there's Skip-Bos. And then there's multiple numbers of 1s, there's multiple numbers of 2s. I actually don't even know how many of each there are. So the probability of getting your number is quite slim, but it's still there. So probability in playing games is a big thing. So let's look at this one. For her work uniform, Missy has a choice of 3 colors of pants. So she has black, khaki, or navy. Okay, after she chooses her pants, well, then she has 4 choices for shirts. She has red, white, green, and yellow. Okay, so our events, we have right here, we first have to choose our color of pants, so we have 3 colors of pants, and then we choose our color of shirt, which we have 4 different colors of shirts that we're choosing from. So when we create these tree diagrams, so we always want to start out with what is the first event, what are the possible outcomes, and you're going to write down those possible outcomes, okay? So the first event is her color choice in pants, okay? So she can either choose black pants, she can choose khaki pants, and she could choose navy pants. So that's the first event. Which color pants is she going to pick? Okay, now after she chooses her color of pants, let's say I'm going to put my black pants on today, okay? Well, then she has 4 colored shirts to choose from. So from our black, our first event, we have 4 branches again, and she could wear black pants with a red shirt, black pants with a white shirt, black pants, green shirt, and then black pants, yellow shirt. So there are her possible outcomes with black pants, okay? Let's say she didn't choose black pants. Instead, she chose khaki pants. What would her color of shirts be then? Well, they're still going to be the same 4 color shirts. She could choose red. She could choose white, green, or yellow. Oh, there we go. Add my L in. Okay, now, let's say she chose navy pants. Well, if she has navy pants on, what color shirts could she choose? Yep, you're right. She could choose all 4 of those colored shirts again. So red, white, green, or yellow. Okay, so again, there's our tree diagram. We can list out our sample space. Again, we use these little squiggly parentheses. A lot of times sample spaces you see abbreviated. So instead of writing out black pants, red shirt, we put BR. Black pants, red shirt. black pants, white shirt, black pants, green shirt, black pants, yellow shirt, okay? Or khaki pants, red shirt, khaki pants, white shirt, khaki pants, green shirt, khaki pants, yellow shirt, okay? And then all the same with the navy pants. So navy red, navy white, navy green, navy yellow. And there is our set of all possible outcomes, our sample space. Okay, so in this example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Okay, now let's take a look at our probability. We can use tree diagrams then to find probability. So let's take this first example. What is the probability of getting black pants, green shirt? Well, how many of our, you can look at the sample space over here, or you can actually look at the tree diagram and find black pants, green shirt. So there is one possible outcome for that. Or you could look over here. Here's that black pants, green shirt. So one favorable outcome out of 12 total outcomes. So there's our probability, 1/12. Okay. Then last one. Probability of wearing black or white. So we're looking through and finding which of these have black. Okay, well, the black red, black white, black green, black yellow, those all have black in them, so they count. Now, khaki red, no black or white. Khaki white, now there's white in the outfit. Okay, khaki green, khaki yellow, no black or white. Navy red, navy white, there's another one, navy green, navy yellow. So we're looking for any of them that have black or white in them. So we have 1, 2, 3, 4, 5, 6 out of 12 total outcomes, which that simplifies to 1/2 or 50% chance. Okay, if you notice in both of these examples, guys, there's something what we call a fundamental counting principle, where we don't actually have to make the tree diagram unless we want to see all the sample spaces. If we just want to know how many possible outcomes are there, look at the events and how many options we have in each. Okay, we had 3 possible outcomes in the first event, 4 in the second outcome, or second event. If we multiply those, 3 times 4, that gives us our total possible outcomes. Okay, and let's flip to the first page real quick. We'll do this here as well. So the first event was choosing Friday or Monday. That was 2 possible outcomes for that one. The second event was how are we getting there? Fly, drive, take a train, or take a bus. That's 4 possible outcomes. We multiply them. That gets 8. And look at our possible outcomes here, 8. So that's a way just to find total possible outcomes. That way doesn't actually tell us what are all the outcomes, okay? Hopefully that made some sense, and you are more than welcome to reach out to me, ask me questions, and hope you all are staying safe and you're all healthy. Miss you all.